at practice for 2 weeks or more. I don't think it's connected yet. How do you know? There it goes, right? Yeah. So we'll go ahead and get started as people come in. Can everybody hear me okay on this? I get to practice for 2 weeks when I have to wear one of these again, so this is good. So first time I've done a lunch and learn mic'd up. Appreciate you guys having us here. For those that are watching remotely, welcome as well. Today's program is on understanding eastwood drainage. So as we finish, for those signing in with the AIA numbers, it is a health, safety, welfare SD credit and also US GBC credits. If you need that, Julie will email you a certificate and you can self-report your US GBC credits. So with that going, I'm Randy Campbell, the Architectural Sales and National Accounts Manager for ParexUSA. I'm based out of Atlanta. So for those of you listening back in Atlanta, I can't wait to get back home because it's been a couple of weeks now. But I've been with Parex now 10 years, in the EIFS business 32. So have seen a lot of things come and go in that thing. And this is Julie Montrose. Julie is our Midwest architectural sales and national accounts rep. So she is here local in Chicago to help you out. So as we go through this thing, we're always here to help you. I always think that EIFS is something that if you're doing that, and I know the type of project that you do, you probably use a lot of it, or most of the time you do, especially hospitality and the restaurant business. So it's always good to sit down and discuss details and so forth with someone local face to face, and we're happy to help. So does anybody here know Parex? Any show of hands real quickly? You don't? Okay, that's bad. As of last May, we were acquired by Sika, so most people probably have heard of Sika Corp, right? So we're now part of one of the business units of Sika Corp, coming up almost a year. So it was a global acquisition, and we're happy to be part of that group. We still are our own business unit operating under Parex, so we just get to do that. We're a Sika company, but they also own RMAX, Sarnafil, and the sealant line, which it gives us the ability to kind of sometimes marry things together, such as sealants and EIFS for a joint warranty, the RMAX for insulation for stucco and things like that as a single company. So big advantages. So we're happy to be part of them. So I'll jump into the AIA part here because we're running a little bit behind, and this can take about an hour if I go right. So what do we want to talk about today is the key benefits of EIFS. And I won't bore you with the history of it because it's been around for so long and I know you use it, but we'll recap on that a little bit as well. But also some important considerations to think about when you're using it, and then how codes have impacted EIFS over the years, and how we really are written into there now, all the way up into the 2018 code. Kind of look at the components that go into the assemblies, and then why drainage is important, and then how to look at the different systems. So let's just jump right into that. So EIFS is being, I mentioned I've been 32 years. It was originally promoted as the way to prevent thermal bridging, back in the 70s, late 70s and 80s even. So that's really come full circle and now really part of code. So it was originally, before it was code, this is what the systems came to the U.S. to promote, insulating on the outside with continuous insulation. They really were developed in Europe as some coatings and renderings, they call them, and a lot used over masonry, but came to the U.S., and that's where it was really introduced to stick-built construction. Unfortunately, we went through a rough time period with that learning curve in the late 80s, early 90s, but that has evolved now, and the systems are much more advanced and work very functional as claddings nowadays than they do. So if you look up what EIFS is in the glossary of Chapter 2 of the Building Code, it's going to give you that definition: non-structural, non-load-bearing cladding, adhesively or mechanically fastened. It's a pretty basic description of what EIFS means. A lot of the manufacturers now are going to using the buzzword CI instead of EIFS, but at the end of the day, it's in the code is EIFS, and the specification section is still EIFS. So I like to keep still saying EIFS rather than continuous insulation systems. This is our industry association, and I put this up here because if you are not familiar with EMA, they're really the ones responsible for how we've evolved throughout the years, what's written into code, very active in ASTM committees, ANSI committees as well for testing and establishing protocol for the products universally across our industry. But also, if you want to remember that website, they have an amazing set of details that are non-branded. They're done very high-end 3D modeling kind of details. So they're available for you as an architect to log in and request to get. And it's really a nice set of library of details. And it's not manufacturer specific, so it can help you across the board as you do things. They've been really part of our business since the 80s. It used to be basically held limited to just manufacturers. Now it's available to architects, contractors, suppliers of raw materials to us. So it really truly is an industry organization now. So very, very good group. So we touched on the benefits. I talked about the CI part of things earlier. We use typically EPS as the continuous insulation for EIFS. However, that's evolved now that XPS of some types can be used as well to beef up the R value requirements if you want. So we can go from a average about 3.87 per inch with EPS, and I say that because the ASTM criteria is 3.6, but manufacturers will test and have different readings on that. Some go as high as 4, so we kind of use an average of 3.87 in the middle. But R5 for XPS comes with a trade-off of cost a little bit, but sometimes it is a perception issue, or if you want to do you've got a CI requirement of R10 and you want to keep that insulation thickness to a minimum for design reasons. So it's something good to look at. There's some specific types we have to use, and we can dial in that in a different conversation, but great for insulating. Very flexible materials as well. They're acrylic based. They're not elastomeric, properties that they work in this direction, but in the flexibility standpoint, they flex and move very, very well. And then the aesthetic design flexibility, I don't know that most people even touch on what you can do with that because there's so many finishes that are available to you now. It's been really a tremendous growth in the things that the manufacturers have launched in the past few years they're just really fabulous to be, and we'll show you some at the end. But it's also a low maintenance type thing. It's not a maintenance free, as any cladding's not. Simple wash downs, through a maintenance routine, checking sealant joints periodically to make sure they're still intact and to do. But it's not something that requires recoating every 2 years in that aspect. The other advantage people miss a lot is the lightweight, especially in larger scale construction. So if you have a cladding that's only a pound and a half per square foot, you're designing your wall with L over 360 versus something that might be L over 720 with traditional masonry. So there's a huge cost savings when you back it into your metal packages on jobs for using the more lightweight type cladding options. And because it is insulative and has some innovation credits with air barriers involved in too, there's LEED credits to go with it as well. So where is it used mostly? I'm going to focus mostly on commercial, but hotels, casinos, restaurants, that's a big part of our business where we're used. Office buildings as well. Mixed use is still very popular. Even in the downtown segment now, panelized EIFS become very popular, prefabricated off-site, and the panels are erected on-site. Speeds up the process. The quality control is much better in panelization. So we're starting to see more and more of that leading our products into more healthcare and university type projects. some of the commercial applications with just some photos here real quickly, but you can see various types of the retails, casinos, car dealerships, your hospitality of all types, and in the institutional thing. So the healthcare and things are coming back for us in the last 2 years in the market share. And then even residentially in pockets. In California, it's huge residentially, Arizona, Texas, and believe it or not, like coastal New Jersey. So things you want to look at when you're really thinking about EIFS. There's two types. They really are the same type, but they're both defined as a Class PB system, which is polymer based. Previous years, there was a Class PM system that was in the market, and just due to unpopularity, most of those just disappeared. It was a thicker, almost a modified stucco type application, kind of in between EIFS and stucco, if you weren't familiar, but it just wasn't very popular, and they most have disappeared from the market. But your standard system, as you see on the top, and we'll dive into this a little bit later specifically, but you see there's no air-water barrier on the sheathing. So it's simply an adhesively applied EIFS system to sheathing. There's no drainage, no air barrier. It's still allowed. There's nothing to say you can't do that anymore. A lot of people have that misconception that, I'm not allowed to do EIFS, it's not drainage. That's not true. And I'll touch on that a little bit when we get to the code part. But then the bottom is the drainage assembly. They're both still Class PB systems. It's just the bottom one has now the air-water barrier and the drainage channel to allow incidental moisture to escape the system. Because each is a barrier assembly. Either way, they're barrier assembly. So they both really will want to rely on keeping that water out in the first place. But the top method, if water does get in, then it has nowhere to go. So you still want proper flashing, proper sealants to keep it out. It does. The bottom is not, hey, I can design my building now to let water in. It's not a rain screen system. One of the biggest things that I see, and I always tell people, I've been doing this for a while, but a lot of the negative connotations we get is because we're always specified at the minimum performance standards that we offer. Because we all have good, better, best of different things. Finishes, impact resistant opportunities, and it's always standard impact is the biggie. And it's probably 95% of what hits the market. But you have the opportunity really to go in and do higher impact system or products in specific areas of the project. You don't have to do the whole project in high impact. If you have entries or drive-throughs or things like that, and you want to beef up the impact resistance for heavy foot traffic or things like that, you have the ability to design that into the system, and no one would really know other than probably the maintenance people that they don't have to attend to patching repairs downtime. So that's something to think about a little bit, just looking into what you're doing. Can I make it more impact resistant? Yes. Unfortunately for both of us, our contractors are our evil enemy because they want to BE it out for you because they never bid it in the first place, and it's easier for them to give you some money back than include it. And it's not a big cost thing to do it. So that's something to think about as doing it. The higher impact systems aren't going to help us with drive-through things like columns and things like that where a vehicle might hit it. That's just, if we're going to have vehicle or forklift damage that we're worried about, then we probably need to look at something that's a different type material. But for basic foot traffic with people and general maintenance, people abuse, I would look at upping the impact resistance of the assembly. So now we kind of look at the two a little bit more in depth. So here you see this is where we started. So this is kind of where, when the water intrusion, if you guys probably have heard that, started with EIFS. This is basically what was being used, but in really a more loose fashion. So everything was going over sheathing, but what happened in the residential thing that led to that was there was no flashing. There was most of the time no caulking, no kick-out flashing. So the homes were being designed just to let water in the first place, and it had nowhere to go. And a lot of it was over wood-based sheathing, especially OSB. And so it really led to what you have is being called drainage now because it was written into code that we had to have drainable assemblies. And they evolved very quickly from very crude things that we'll take a look at to some pretty sophisticated systems that work very well. So we show the dense glass on the schematics there, but plywood's a good substrate. Any of the other glass mat sheathing products that are on the market, cement board. And then now you have the drainage assemblies. Basically the same concept. You could look at a building and really not know which was there because once it's covered, once it's adhered to the wall with the insulation part, everything remains the same. But here you see the air-water barrier. You see the drainage plane, and then the terminations at the grade to allow the moisture out. So those are the basic differences. And we'll kind of touch base as I go through this on each one of those steps there that's highlighted, why they're important, and how to do that. Because one thing is you do, simply putting the air-water barrier on there doesn't make it drainable. If we don't have the detailing to let the moisture escape, such as flashings at floor lines or at grade, and those terminations, it has to have somewhere to go. So it's not just the air-water barrier that gets us there, it's in the detailing as well. So why drainage? So, incidental moisture can occur from a lot of things. One, from bulk water intrusion is the main way, but also just through, climate, temperature controls going through, air passing through, condensation forming at a certain point in the wall assembly, and leading to that as well. So it helps prevent all that from really entering into the wall cavity. You look at a lot of the whole wall assembly science now, and a lot's made over the permeability of just the air-water barrier, but there's more to it because the whole system becomes part of that permeability of the wall. So I talked earlier about XPS and EPS. XPS has a much, much lower perm rating than EPS. So like 0.5. So EPS, there's a trade-off also from the R value part. You're going now to something that, is really a lower perm rating. So you got to kind of look at your whole wall, what you've done to make sure it still breathes properly. You guys do any water vapor modeling on any of your projects or any dew point analysis or anything like that, having run any models that you do throughout the country to do? I know there's some basic things now on some websites where you can type that in and it'll kind of tell you if you may have a potential. It doesn't really go into in depth to it, but I think the ICC has a little site now where you can kind of check your energy code compliance, but it also tell you if you're meeting the air water barrier requirements and things like that too as well. So reach out. So codes. I flipped this around a little bit. We used to do this at the end, but I think this is very important because as it's come about, there's becoming more and more misconceptions with EIFS of late. The fires in London that happened a couple of years ago really brought a lot of scrutiny to things in the United States that use foam plastics. So as EIFS is a cladding, we meet the Chapter 26 requirements that they have. Chapter 14 is where you would define EIFS in the first place, but we also, with the drainable systems, we're meeting the air-water barrier requirement in Chapter 14. And as you look at the energy codes, the CI requirements are met. So as a cladding, it's very unique. From that sheathing out, it's a tested assembly, and there's not many other claddings that are out there that do all that in one. So you think about that. We'll touch on the fire performance a little bit kind of first, but energy code wise, with EPS up to 4 inches, you can just about meet any climate zone requirement in the United States. So if you're, zone 6, your CI requirement is going to be that you're going to be able to accomplish that by just using EIFS and not have to worry about testing that goes any further than that. The drainage is there with the air barrier. EIFS, the EIFS industry had to do NFP 285 testing kind of as a pushback from the brick industry back in the 90s. It wasn't even called NFP 285 at that time. It was UBC 26-9. So as claddings, it's had NFP 285 much, much longer than most out there that you're seeing on the market now, because they've had to react to the recent code changes to do that. And a lot are simply just engineered analysis, where these are actually tests as a full assembly. So we're written into codes all the way up to currently into the 2018, and you're going to find EIFS in the chapter 14. You're going to find your air water barrier in chapter 14. There are some ASTM criteria now that go with that. So the 2568 defines the overall encompassing performance criteria for the systems. The WRB is defined by the same. And then, basically what you're going to have is from the manufacturers. If it's type 5, we want drainage. And that's pretty much across the board. That's not written in any of the codes, but any of the manufacturers will say if it's a type 5 building, it should be drainable. We're just going to go back to the 90s when we had those issues. So we kind of have, if it's has a bed in it or someone lives in it, drainable. And even the drainage efficiency. So you just don't say it drains. There's an ASTM criteria for that you have to meet to recover 90% of the water that's introduced behind the system. So it's not just simply a self-proclaimed drainable system. You do have to go through some testing methods with it of your application. NFP 285, this has kind of been a big one for us in certain markets. So if you guys haven't ever seen the test chamber, how they do this, it's a fire that's introduced from the inside with blowers that go out upward as well, and it really does it at a window opening. So it tests the flame propagation of the cladding assembly to do that. It's expecting to burn somewhat, but it measures how it would spread. So you can see there's a basic test chamber, and really that's written in now. It used to be, certain heights of buildings had to have NFP 285, but now if you're using CI, you pretty much have to have it on everything. So it's kind of really become the chapter 26 thing in driving. After you have foam plastics, except for certain exceptions, you have to meet NFP 285, and EIFS is fine with that. So, and also E119, which is your 1 hour, 2 hour, and even some cases up to 3 hour ratings that are available. So from a fire performance standpoint, don't shy away from it. A lot of people think that, but it's been very well tested in this as a system. Let me see if I have a. And how it meets that. So you may think, hey, how does polystyrene not burn? But when it's encapsulated in the cemented space coat, it protects it well enough to perform well in these assemblies. So this is a critical part in the detailing of how that goes. You never want to have an edge showing in EIFS that's like this at all. Any kind of penetration, window, pipe, everything should be out. That's traditionally called back wrapping. And that actually goes back behind this. So it's fully encapsulating the edges of the expanded polystyrene. So that's how you can take plastics and foam plastics and pass fire testing. A lot of the insulation manufacturers will do this for other claddings by using some type of aluminum flashing or something that aspect to cover that foam edge. And then you have to make sure now that's used in your design. So you can look at their assemblies with various claddings, but you have to really see what they did on edge treatment, how they passed. Like brick, for instance, with XPS, you had raw XPS around the window opening. You have to do something to protect that before that would. And it's in their guides. It's just very well missed mostly. Anybody got any questions on fire performance? Does that come up much? You're here in one of the hotbeds where this is a big topic in the United States. So New York and Chicago. New York is kind of off the chain right now, but it does meet all the fire performance requirements that you have and should be there. So let's look at the energy codes, and if you guys do all the tables, this one might be a little bit older, not maybe the 2019, but if you're familiar with them, you got your climate zones and your construction type. So if you look at a metal frame wall, let's just pick Climate zone 4. So we see our CI requirement 7.5. You know, we can get there with 2 inches of, or inch and a half, 2 inches of EPS. So there we meet our 7.5. Very common application for EIFS. Expanded polystyrene is not expensive, so going from 1 to 4 is not like it doesn't increase the total overall cost of the system by 4 times. It's just one component. So it's a very minimal thing to do. So the air water barrier part of it, with EIFS, with drainable EIFS, that's part of the assembly by nature. So we had that there for the drainage parts that we started back in the 90s again, really before air water barriers were really part of the code. They're how the industry adjusted to drainable EIFS. So some of the fluid applied air barriers on in the market now for EIFS really kind of pioneered the fluid applied air barrier. You know, things are, you know, just gone crazy with everybody with a fluid applied. But the original ones, really the non-asphaltic types that are acrylic based, really kind of started with the EIFS industry back in the 90s. And we needed a way to still adhere our systems to. So they're acrylic based, not asphaltic, things that interact with the foam. They're not silicone based, so they don't interfere with the adhesion. So it's really important to do. Also, if you're doing that, any kind of your time you're using EIFS, any air water barrier behind that EIFS needs to be by the same manufacturer as the EIFS. Because we can back up all that testing, and that's how it's done. Would there be some compatibility issues? Probably not, but it's never been tested. And so no one runs around testing with our competitors, you know, to make sure their product's okay. So from a testing standpoint, it should always be, you know, from air barrier out with the same EIFS manufacturer. The great part of that is these air barriers are code acceptance, so you can continue to use that air barrier for the rest of the project if you want to. So if you have a project that's 50% EIFS and it may be 50% of a masonry cladding, you don't have to worry about changing air barrier types. You can use that air barrier behind the EIFS for the rest of the project. You know, and again, you go to the code. This is a kind of an amazing part of the code. It's basically just a material behind the assembly to prevent water intrusion. And, you know, as air barrier requirements come into play with these products, it's even more loosely written in the code. It basically tells you that the sheathing is an air barrier, or, you know, so lots to made of that with the product. But if you look at the different functions of these systems, water's one, but the air barrier requirements of what's written in the code are like sheathing, plywood, but that doesn't get you all the way. But the ideal is to prevent, on the air barrier functions, keeping the air out. That's what causes that condensation that we talked about as well. So air leakage into the building, hitting that metal studs, can create condensation in the cavity just from the differential temperatures. Warm air meeting cold air on a metal stud. You're going to get the same thing happening on your cup, condensation forming as the heat meets. So that's the idea of the air barrier thing. Treating all the penetrations, making sure everything is airtight, sealed up is a very good part of the design. And when I mentioned earlier about just putting the air barrier on doesn't mean it's that way. It's got to be done detailed properly so that all the penetrations are tight. You know, if you're using a sheet good product, that the lapping procedures are done correctly, all shedding that water out and getting the air, not only water, but air. When you look at the vapor barrier function of them, because these all have three roles: air, water, and vapor. Because by default, they're going to also do vapor control. And you have the different classifications. So typically, you're going to kind of want to be something in the class 3 range of something 1 to 10. That's something that breathes. It doesn't, you know, of itself as a liquid applied coating, it's not giving you vapor penetration. Because remember, as I said, once you start putting on top of it, will control that. So air water barrier that's a perm of 10 with an XPS on it of 0.5, well, that perm rating of that wall is never going to be better than the lowest one. And a lot's made of air, water, and barrier, hey, with the permeability, of your product is, but you have to look at what you're really doing on the whole wall, because that's only one component. So the fluid applies to do all three: air, water, and vapor control. There's different formulations. So if you had a case for, hey, I got to have a vapor retarded product, they're available. Then you want to look at, hey, I may not want to have insulation in my cavity, or I want to make sure my HVAC is going to handle the load on larger projects. Anybody here ever really get into this too much on the vapor flow of the wall to think about? Yeah, you just always, I suggest just think about the whole wall assembly, what you're doing, rather than one particular product. So the codes changed a little bit over throughout the years in 2012. So if you're still doing projects that are operating under 2012, there were exceptions when you had to have an air barrier. Climate zones 1, 2, and 3, basically. So Florida and up into the mid Georgia area, Carolinas. Those are exempt from even having to have an air barrier. 2015, they took that away and made that only 2B, which is coastal Texas. Strangely enough, really humid place, but coastal Texas is exempt from the air barrier requirement in 2015. And then in 18, nothing changed. So now even Miami they have air barrier requirements. There's a lot of people there getting used to doing things differently than they had to in the past. So all that, the way we've always done it, doesn't apply in South Florida anymore. Same thing with CI. They have some CI requirements now for climate zone 1. But that's something to always think about too. So states have all these various codes now. There's a handful on 2018, but there's still quite a few on 12. So they have different requirements of what you have to use and what you don't. Nothing wrong with going to the 15, 18 criteria and just sticking with that. You can always go above and beyond. For weather barrier options, you've always had different things. I mentioned in the 90s when drainable EIFS came out, the first reaction was the manufacturers didn't have products. So the first thing that they did was they put EIFS up over building wraps. And so you had your traditional building wraps, even 15-pound felt, that the EIFS was mechanically fastened to. And that's how the early drainable EIFS systems were done. It was a very short period of time. And there's still some situations where you can do that over the wraps. But all that fire testing and things I showed you, that goes away. So like anytime you're not using the EIFS manufacturer's weather barrier, and I know you guys do a lot of restaurant facilities and so forth that might do paper, and they're wood framed as well. If it's non-combustible, it doesn't matter, but it's still some options out there to do. But they're relying upon fasteners to put them in place. So you got a lot of fasteners holding up your air water barrier now. Is it lapped properly? How are the windows, flashed out properly? And then now I have to mechanically attach my cladding to it as well. You're putting a lot of penetrations in an air water barrier if you do the fluid. You have the pill and sticks out there. They're not really used behind EIFS that much, but they're still an option if you see in the air water barrier market. Pretty labor intensive. Most don't have a very long exposure time limit to them, maybe 45 days. Same thing with the papers. They don't have a long exposure time during the construction process. So smaller projects that might work, but larger scale projects that have a cycle to them, that's really going to become an issue when it's going to be exposed maybe for 3 months or so. But the disadvantages of the paper and the fluids are, you see all the fasteners, but even code lets us use 15-pound felt, which is like the minimum, thing to offer. When felt gets wet, it's going to deteriorate, rip in the wind, and a lot of fasteners through it to keep it in place. So the fluids came into play, and now they go on. You typically, as even in fluid applied air barriers that are not behind EIFS, you have your joint treatment, which you can see on the top right photo that the joints of the sheathing have been treated first. Typically, they're fabric reinforced. for movement in between sheathing joints. I always tell people there's not a lot going to happen there where that logo with a triangle is. There's not a lot happening there as far as air water leakage. It's the joints that are the key criteria. So your joints and penetrations, getting those reinforced with a fabric or even a very elastomeric STPE product are very key in how you do that. Because that's where you have your air leakage or water leakage potential, highest risk. But most have a 6-month exposure time, some a little longer. So the products can go up, be left up to 6 months without any chance of the UV starting to deteriorate the surface or break down the product. No fasteners to put it in. So now I'm not putting my air water barrier up with fasteners. So I got no penetrations so far. If I use another cladding, I'm going to have some, but I'm not really doubling up on that into my air barrier. Because with water leakage, a lot happens if they miss the stud with a paper. So if they put a fastener through the sheathing and doesn't hit the stud, a lot of times their first reaction is to take it back out. You have a hole, and so that happens quite often, you would believe. But with EIFS, the wind loading of how we adhesively attach is so vastly superior to mechanically fastening over paper. If you were designing a larger project in a coastal environment or something with a high wind load to it, the mechanically fastening wouldn't even come close to meeting the local code requirements. Where this will meet any wind zone requirement that we have in the U.S., including the Miami-Dade, NOA high velocity hurricane zones. And it's over masonry adhesively attached to EIFS, like off the chart. Couldn't even test it. Typically, the failure comes at the sheathing metal stud framing, like in the hurricanes or things like that. You'll see the failure comes here first. This will still be attached, but the failure comes in these screw attachments or even at the spacer to the sheathing attachment before this fails. So if you design your project to meet local wind load requirements in your framing and sheathing, EIFS is going to be perfectly fine to go right over that. So you don't have to do any additional steps. If it goes on a 90 mile an hour zone versus 150, it's the same application. Just you have to design your framing to meet that. And I touched a little bit that these really do dual functionality on the fluid. It's really a tri-functionality of air, water, and vapor. What do you guys do specify most? Are you doing fluid or paper or both? Or does it vary with clients or fluid? It's a good thing. They also come in different formulations because, especially in the EIFS industry, which really evolved from a lot of plastering contractors, guys that use trowels versus spray equipment, there's formulations out there that can be sprayed or roller applied, and even trowel applied out of the same material. A lot of them outside the EIFS industry had to have special equipment to spray only. So a lot from the EIFS side of things, our air water barriers have multiple application things. A smaller scale guy doesn't have to have some expensive equipment to do, a smaller job with a smaller crew. They perform the same, they just go on a different way. In a lot of cases, it's still the same product. Mill thicknesses of air water barriers throughout can vary. You take those larger companies that are outside the EIFS industry, some of them are 90 mils thick. Typically you look at the 4 to 5 major EIFS manufacturers, we're going to be in the 10 to 15 mil range. But when you look at them side by side with testing, those thinner mill things meet the same exact criteria. It's about the formulation of the product. So with the solids contents and the acrylic base, this doesn't need to be 90 mils to meet this, where this one would. And it kind of doesn't work like, hey, you have a 10 mil product, but I want it to be 40, so I want you to put it on 4 times as thick. Because the perm rating goes, things change. So they're designed to be put on at the thickness they do. Yeah, something that's a 10 mil perm put on 2 coats goes to about a 6. So it does affect that rating as it goes. And also they can't go on past that thickness because of you put it on it, try to put it on 40 mils, it would just sag, wet material. Like putting on paint too thick. You treat your rough openings with the same material generally and the same fabric that you did at the sheathing. So you can see some step-by-steps here how we end up with a completely monolithic membrane in the rough under opening. Same product that's on the wall. And the beauty of the fluids are you can do this in your windows first, get windows installed. So if your cladding guy is not there yet, you can at least treat rough openings first. Windows are in, and then because it's monolithic and it doesn't matter, about lapping, they can come back and do the wall at a later time. Can't do that with paper. Because to do that with a paper, it's got to be on the wall, and then the peel and stick type membranes then have to be in the wall to come over it. So it offers some great advantages over paper as well by sequencing. Typically always we still want to do a good seal pan at the bottom of most windows, and you see here what it's showing is how critical it is to, after the application of what we just showed, we now put the seal pan on, and we want to come back and put a little strip there over that end dam of the seal pan, bringing any water down that window jamb into the pan. So there's a lot of little critical things like that that people miss sometimes. That's how you get everything flowing to out of the system, is in the detailing. Same thing at different things. So if you have a metal flashing at grade, or say a floor line, you still tie that back into the flashing. So there's a separate little application. You would do your wall, set your flashing, separate little application only with a certain area, diverting that to the flashing so it can go out. So the drainage plane, how do you get that? You think, okay, people don't quite understand how drainable EIFS works. Looking at that photo, but what that is that gives us now the means for the moisture to migrate to the bottom. It uses gravity. So when you hear about channel adhesive EIFS, that's what they do. It's put on with vertical adhesive with a notch trowel that's applied to the wall so that the ribbons run vertically. They don't line up or anything like that. It's not a very scientific thing where you've got to have it lets gravity do its thing to migrate the moisture down. Most cases, you're not going to go more than 3 stories with having an exit point anyway, so it does allow it to come down. It does give you, believe it or not, it's the notch trowel is so big that it gives you about 1/8 of an inch drainage plane. So if it's put on properly, there's about 1/8 of an inch gap between the EPS, small gap, that allows that to work as your drainage plane. So you don't need a drainage mat, anything else introduced into that. The ribbons of adhesive are a little bit bigger than we're showing here. It's a 1/2 inch wide and 2 inches apart. So they're going to be very well spaced apart, but very thick as well. So if you think about like a ceramic tile application where you want to put down your thin set mortar and you put your tile in and you move it to get full coverage, you don't do that with the installation of this. Put on the wall, put in place. We don't want them sliding the board around. Quite the opposite. And then your drainage plane. So you typically on hotel construction, we recommend at least every 3 floors. You can do it every floor if you want to, but there's no written rule to how often you drain it. So it's manufacturer's guidelines, and pretty much across the board, it's about every 3 floors is what we recommend doing. And here you can see, some great examples here. You see the floor line. We want a metal coping up there to prevent water out. I mean, the days of people using really decorative EIFS trims as parapet caps have gone away. Still, certain climates they do. California wants to use some really large ones with no slope, but kind of a design trend out there. But all these exit points are real popular with how you get. This is critical to how you get the moisture out in the first place. So here you see on the photo on the opposite how they're putting the adhesive onto the EPS board itself. So it's not put onto the wall first; it's on the 2x4 sheets of foam, so that when they put that up, it's vertically notched. The other ways, when I mentioned about the papers and so forth, to do that now, we got to either start grooving the back of the insulation or introducing a third-party drainage mat. So those don't really have any fire testing to be that way. And the other part about groove foam, now you're starting to lose R value, because real R value is becoming a thing now that's popping up. And so something like that started out at 3.87 with all those grooves in it. Its real R value would probably only be about 2. So this allows us to keep our real R value. And here you can see a full how they're putting it on. Best wind load, no fasteners. So that's why it's good to use that fluid applied that you do, because that allows you now to keep doing that with adhesive attachment. And then how do you drain it at the bottom? It's a very simple thing. Throughout the business, all manufacturers have some little gadget that they put at the very bottom termination to prevent clogging of that drainage plane. That's all it's there for. Just because the mud and the base coat materials, you don't want that to interfere with that. So these little strips kind of work as a little coupling membrane, so to speak, to allow the water still to come out, and we don't have clogging from the mortar that was used to put the system on. The plastic accessories, I don't know if you've seen those used or not. They're PVC accessories with weep holes into the bottom, and they're really good to use at grade only or type 5. And why? It's because that NFP 285 thing I referred back to earlier. Because you can imagine on that fire you saw what would happen if I had a piece of PVC that was encapsulating the end of my foam to foam, plastic to plastic. So they wouldn't pass a fire test in a window. And that's why they're limited to really at grade, unless it's type 5 where your fire performance isn't required. They make a nice clean edge, but they have to be used really in the right place and the right location on the project. So finishes, I'm good. You have different types, and we have things out there now that are coatings that go on. Just to say like metallics. So if you're trying to emulate a metal panel, there's some coatings and applications that go on at coatings. So once we get the EPS and the base coat on, and we start trying to finish the system, and there's a multitude of opportunities for you now. The coatings are there for the really ultra smooth surfaces. For instance, most of the BMW countries or dealerships in the country for the past several years have used a very smooth, almost drywall type finish on their EIFS that's finished with 2 coats of a coating rather than a finish. It's a really super smooth application. Then your finishes. Typically, they're all acrylic based, unlike stucco where they're cement based. These are all acrylic based all the time, and you have multiple opportunities there with them. And even some, elastomeric properties can be added to them, although it's not like an elastomeric coating, because they have aggregates in them, and aggregate doesn't stretch. So you have to be really careful if you're looking at that. At a textured elastomeric, most of the time the little footnote says the film thickness is what the elongation is, and the aggregate doesn't make it stretch. But you have a bunch of opportunities available. You can just see some good, from Adobe style to getting really creative with color and plain smooth. But even now, even emulating wood, you have the ability now to come in and do thin veneers as a finish option. So you can use thin brick or thin stone as a finish versus the acrylic. And even marrying the two together. A lot of projects now have thin stone and EIFS and other claddings as well. You could basically change from a standard EIFS acrylic finish to a thin stone thing and never really break the plane in the assembly behind it. It's not done by templates. You pick your own veneer. So let's just say you had a client that used a particular brick type or whatever. If it was available in a thin brick version, you can do that. The other photos, the metallics, those were from a like a Honda motorcycle dealership that did the they VE'd out some ACM panels and went to a metallic type EIFS. That's probably the most labor intensive and contractor driven thing for results. The products are there, but it really is a true, you have to do a lot of time to make those look right. So you have that, and you can take a look at, but the beauty is now you can get the textures in a metallic. So it's not quite as the same, but it kind of takes that labor intensity out of there, so you can end up with a metallic look now, just from a trowel applied, no spray equipment. Those have to be sprayed, so you don't see them painting cars outside too much. There's a reason. But you can get the metallics now in textures. And the wood graining is basically a very simple technique, but these can look really, really, really great. Replacing cement board type options or whatnot, planks. This is becoming really, really popular in the hotel industry. Quite a few projects doing that. And it's really just with a very simple wood grain rocking tool. Same finishes, just it becomes a different technique. Have any of you used any of that yet on your hotel projects? Because it's kind of becoming a really big thing with value engineering out some of the cement board siding planks on the hotels now and going to the simulated, and it's really done very well. So here you see these are a couple projects that are using the thin brick. So it's basically everything we talked about. So now I'm just changing what you use as the cladding. If you think about you're using thin veneers and you're doing insulation behind it, it's really kind of a challenge to find your fire testing now, but this takes care of all that too, because it still falls within that same fire testing of the EIFS thing. So this is one's a project. This one here is a project in Myrtle Beach, and then the other one's in Washington State. Surprisingly, thin brick has been a very popular thing to do, but these are now in the market, by more than one manufacturer. Allows you to pick your own veneer. Fire testing is there under NFP 285. Everything is by the manufacturer except for the veneer. So it single sources a thin brick thing as much as you can. They use a ANSI modified mortar to stick the stone, and it's a ANSI 118.15, which, when you look at type S that you're typically using to bond thin veneers, has a shear strength about 50. These mortars go about 350 to 400 psi. They're very, very superior freeze-thaw resistance. So even if you're doing thin stone, think about doing an ANSI modified mortar versus type S in your spec. Because thin veneers have the same perception problem as EIFS. A lot of people get that pop-off experience. And why is because code is written to a very minimum application standard, half-inch stucco and type S mortar. And that type S mortar does not have a really good freeze-thaw and shear strength test. From a sustainability standpoint, we talked about the CI part earlier. It's a given. EIFS is a very, from the carbon neutrality thing that's trending, there's not a lot of energy required to produce EIFS. It's a very, very low footprint that it leaves. And then kind of summary part. Anybody have any questions? Because I did that right at an hour, which was good. And I felt like I was going fast, so. No questions? All right. You can go up to 4 inches. 13? Mm-hmm. The thin, it's 4 because the weight, right. And you see these, and now I'm done with the AIA part, I can tell you, but these fasteners were done there, and that's really a belt suspender in the fire testing we did with the heavier veneers. because in the event of a fire, you don't want a catastrophic failure of what the laminate is. This is holding this into the studs. These are at every three. All it's doing is holding that until it can be removed, period. But you can go up to 3 inches. The photos I showed, so let's just say you wanted to do a fake column. You could go 2 inches of foam, bump it out with a foam shape. You don't need additional framing. And there again, this is an L over 360 thing on a larger project. So we don't need L over 720 that we would do with natural stone or brick. The framing assembly could be back. So catching that, designing early within can save a lot of money on a project. The larger the project, the bigger the savings. I have a 24-story going up in Atlanta that's mostly EIFS and thin brick, and I know that it saved 7 figures changing the metal package. No lintels, no shelf angles. And some of the hotel things now with requiring multiple, some of the hotel brands now say you got to have 2 or 3 different cladding types on, and one's usually thin stone. It's a natural into that you can now go transition from thin stone to EIFS without really having 2 different assemblies. Same guy putting it on. So it's really, very good for that aspect. I'm surprised how popular the thin brick part of it can be, because most of the things we do are thin brick. Texas, they do a lot of stone. They put stone on everything in Texas, but a lot of cultured stone there. But we just allow you to pick boral, coronado, whatever you're familiar with. It can be cast or sliced as long as it's within that 15 pounds or less per the code. Chick-fil-A is doing some panelized projects now that they're doing panelized EIFS with their thin brick that they're same pattern they were using conventional, but they're doing the thin version. And a company out of Atlanta is prefabricating those. So I think they have them ready for interior finishes in about 9 days from when the package arrives. It's pretty quick. So they go from slab to doing finishes in about 9 days. Have any of you been involved in any prefabrication projects yet at all? Yeah. We were dealing directly with Chick-fil-A directly. I know there's a package of about 100 and something that this particular group is doing. And it's a way they want to go. Each one's the same, so it made it perfect. They've done it. I think each store is about 45 panels, and the particular contracting group that's doing them actually will erect the panels, but also have some ways to drop in the roof trusses and do the deck, and that's why it's up and ready for roofing and finishing in about 9 days total. The windows, the mullions for the window framing and all that are already installed. All they do is put the glass in afterwards. It's pretty good. I mean, Chick-fil-A is unusual. They're one of the few fast food people that do metal framing. A lot of them are still wood, but you can still prefabricate with wood. You can still do panels prefabrication panels for EIFS with wood framing. You can work all types of weather. Quality control is much better. A larger EIFS project might take 50 to 60 guys on a really big project for laborers and things, or they could build that same building with maybe 12. But when you have a guy that's in the panel factory and he's doing weather barriers every day, he gets really good at it. So that's his job every day. He's the weather barrier guy. He gets really good at it. So your quality control goes up, and it's always done at the correct temperature. It's really amazing how prefabrication in general is taken off. I mean, there's a lot of versions of it in the U.S. where modular is one thing, where they're bringing it into pods and maybe the cladding's put on site, but it is a growing trend. Correct. It's typically non-load bearing panels. We have some people throughout the country that will do load bearing versions of it as well. So I know the Chick-fil-A's we're doing are load bearing single panels, tilt up. They're not having to have another framing structure to bypass, so they're using load bearing steel to do that with. But They build them pretty fast too. Once they get the efficiency down, it's all pretty much the business is really much more of a true panelizer is almost a mini engineering company because they engineer connection points so they can build panels up to 40 feet, but they have to design attachment points for getting it off the truck onto the building to prevent racking, and it's really kind of some pretty sophisticated engineering that goes into what they do. It's not simply just laying it down on some metal studs down on the floor and putting it together. There's a lot more forethought that goes into that trucking and erection, and it's pretty sophisticated. Well, thanks for joining us. If there's anything we can help you guys with, please let us know. So. Oh, thank you.
Thank you.
Thank you.